This is SAT Practice Test 7 from the Bluebook, full math section. Supposed to take 70 minutes. I'm going to do it in about half that. Get a perfect 800 and walk you through every shortcut and Desmos trick along the way. In between the modules, I'll show you exactly what I built to help you do the same thing. You do not need to be a math genius. You just need to practice the right way and actually learn from your mistakes. If you can grind, you can get at least a 700. Let's go. Open up our calculator, just have Desmos ready. I like to leave it like that throughout. Lorenzo purchased a box of cereal and some strawberries at a grocery store. Lorenzo paid $2 for the box of cereal and $1.90 per pound for strawberries. That's a key word, per pound, right? When we talk about, linear equations, right? Per and each are keywords here, right? They signify slope, right? So I know 190 has to be the slope. So it has to be A or B. And then it was an additional $2 for the box. So it's got to be +2, not -2. So that's it for one. Next one, functions question. Throw this into Desmos, right? 25x plus 30. And then we just do plug in 2 for x, right? 80, simple. Next up, 30. We got this graph. It says the graph shows the estimated value in dollars of a tablet as a function of number of months since it was purchased. What's the best interpretation of y-intercept? You'll see these questions about like interpreting x-intercept or y-intercept, right? The y-intercept in general kind of represents just an initial value in a word problem sense, right? Because a lot of times it doesn't make sense for us to have negative numbers for x. So like here, you don't have negative months. So we start at 0. And so 0 is the starting point, right? So this is the 225 should be the value when it was purchased, right? Next one. What's the solution? If you get a question about solutions, those are freebies. Just throw it into Desmos, right? So I type this in. It's not going to show me right away. And you got to know this about Desmos. Desmos needs your equations to be in terms of x, right? And so you see, sometimes you can't click on the answers, but if you zoom in on it, you see that's 4. Next one, triangles EFG and JKL are congruent. Remember, congruent means they're identical. Same angles, same sides, same everything, right? It says where EFG corresponds to JKL, the measure of E is 45, measure of F is 20. What is the measure of J? Well, you see, J and E, they correspond to each other. So if E is 45, J is 45. That's simple. Next question. During the graph, or during the first part of an experiment, a ball is launched from a 7-foot tall platform. The graph shows the height, y, in feet of the ball x seconds after it was launched. Okay. Launched from 7. Okay. During the second part of the experiment, the ball was launched the same way, but from a platform that is 2 feet shorter. Okay, so it wasn't launched from 7, it was launched from 5. That's basically all you're looking for. They're describing a transformation, like a shift down 2 units, right? We just want to see like the y-intercept being at 5. So it's not A here, right? B has 5. Let's see if anything else does. No, so it can only be B, right? Maybe if there was something else, we need to consider something else, but that's it. Ratio, you can write a ratio into Desmos, x to y, right? The word 2 means the fraction, right? 2 is your fraction, x fraction y, right? Is equivalent to 9/5, right? Then they tell us the x, so you see, I just plug that in for x, and I should be able to see the y. There it is. You can't click on it when your variable's at the bottom, you see. If you want to be able to click on it, you just like flip both of these. I don't know if that's something you want to do or don't, or just when you're setting up, but then you can click on it. You see, that's a Desmos thing. Desmos has its peculiarities that you will kind of come across and learn about, right? So that's one of them. Next one, 8. A state fair, attendees can win tokens that are worth different amount of points depending on the shape. One attendee won S square tokens, C circle tokens worth 1,120 points. The equation 80S plus 90C equals 1,120 represents this situation. How many more points is a circle token worth than a square token? Let me kind of break this down for you, because like you'll get questions like these and people sometimes mess these up. There's really not really too much math you do. People overthink these. Here's an equation that makes sense, right? I can say something like this. 3 apples plus 5 apples equals 8 apples, right? How are you going to use this? Well, you see, whatever it equals is important, right? If these units are apples over here, these had to be apples, right? Because if I want to get 8 apples, I can't add like 3 bananas, 5 oranges, apples. So this being apples tells me this has to be apples and this has to be apples, right? So the way you can use that over here, you see, they tell you that it's 80S plus 90C equals 1,120. This is points, right? So this has to be points and this has to be points, right? You'll get a question like this. I've seen it on the other tests. It might be in one of the previous videos actually, right? They're very common. It'll ask you like, what's the meaning of 80S, right? 80S would be like your total points from all your square tokens, right? And thus 90C is all your points from all your circle tokens, right? But what they're asking is like, how much more is a circle token than a square token? That's these coefficients and you just got to subtract them. So it's just 10. Next one, it wants to know what's the solution, right? So these are freebies again. Just throw this into Desmos and we can kind of find our solutions, right? So x plus 9, x minus 9, all of that divided by x plus 9 equals 7. There's my line. You know, so again, sometimes you can't click on it, so just zoom in on it and we get 16. So that's our answer, C. Next one, equation 12t plus b equals c relates to variables t, b, c, which correctly expresses c minus b in terms of t. So you get these questions, they're pretty common. They give you an equation and you got to just rewrite it. They want you to rewrite this so it says like c minus b, right, equals something. So you see that's pretty easy. You just minus b on both sides, right? So that would be it. It equals 12t. Next up, what's the x-coordinate of an x-intercept? If they give you an equation and they ask you for the intercepts, that's pretty simple. Just throw that into Desmos and you can click on those, right? So you see, zoom out, here's all my x-intercepts. There's 3 of them. You could answer with any of these 3 answers, right? It doesn't matter in this case, right? Sometimes they might specify what's the largest, what's the smallest, what's a positive, what's a negative. Here it doesn't matter, so I'll just go with 14. Okay, next one, another function question, another freebie, right? So throw it into Desmos, right? And just ask it to do f of 1/4, right? 2.75. Simple, don't miss those. Next one, circle equation, right? I think on the previous test, there's a few questions about circles. You want to know this circle equation. I think it's worthwhile kind of knowing. You see, it's over here. You want to know how to look at an equation and know what the center and radius are, right? We write x minus h, y minus k in the parentheses. The center is h comma k, right? So here we see minus 13, we want positive 13. We see minus k, we want positive k. So that's got to be A or D, right? And then the last thing you got to know is about, you know, what's this number, the 64. It always equals radius squared. So you do the square root of that number, that's the radius, so it's 8. Next one, circle has a radius of 2.1 inches. The area is b pi square inches, where b is a constant. What's the value of b? Here on your Bluebook, remember, just next to your calculator button, you get a formula sheet, right? They say reference, right? They give you the area of a circle. You should probably know it anyways, though. But area is just pi r squared, right? And so that's all I have to kind of calculate, right? So they told us the radius was 2.1, so it's 2.1 squared, and it'd be times pi. Don't do times pi, right? Like when they ever have like things with area or even volume, we'll see questions with volume. Their answer is always just going to say like some number pi, right? So you don't actually have to multiply pi. People make that mistake and get it wrong. They just want to know what that number would be times pi, right? So 4.41 is how you answer this one. Next one, we get this graph. The question, what was the average rate of change? You got to know this phrase. Average rate of change just means slope, right? If you watch the other videos, you probably see this a bunch of times. I'm sure we'll do more of it in this one as well. Easiest way to get slope, add a table, put in your 2 points and do a linear regression, right? So it says x equals 5. So here's that point, it's 514. And then x equals 7, that's this point, 724, right? Smash the regression button. Here's my slope, 5x, right? So just 5 is the slope, right? Next one, a system. This is simple, freebie. Throw that into Desmos, right? Plus 17, negative 3y equals 9x minus 23. You can just see where they intersect, right? So we need this point. The question wants us to do 39x. So I need this x value, and I need to multiply by 39. You can't copy and paste in Desmos. Or, not, sorry, you can in Desmos, but not in the Bluebook. It's kind of blocked. So click this button. It'll just write the point for you. You see, I can get rid of the y, and then I can just do the x times 39, and I get about 18. The reason you're not getting exactly 18 is Desmos like truncates this decimal, so that's it. But pretty obvious, you know, with the choices we have. Next one, we have this equation. It's an exponential equation, right? So with an exponential equation, here it is. We'll see this a bunch, right? Remember, we're going to write it like this. There's 2 parts to it, basically. There's the number out front, right, which in this case is the 40,000. That's the initial value, right? It's the y-intercept when it's written like this. And there's a number inside the parentheses. That has to do about your increase or decrease. So here, that's a 2. The reason that's a 2 here is, you know, we can kind of read it. It says how much time in minutes does it take for the bacteria in the population to double? So that's why that's a 2 there, because we're doubling it, right? So if I write this, let's break this down. This is actually a pretty simple one. Most of the time, the question's about like, you know, how's it increasing or decreasing, which would be like, we know it's doubling, or it'll be a question about the initial value. But sometimes, and this is more rare, it could be about the exponent, and that's the case here, right? If you think about it, this is actually really simple. If you know 40,000 is the initial amount, right? You want to double it, you would just literally multiply by 2, right? What does that imply about the exponent? It means like the exponent would be 1, right? 2 to the first would just be 2. So we want this exponent to just literally be 1. And that's the question. For what value of t will this happen? Well, that's when t is 790, right? So hopefully that makes sense. I've seen that. People stumble on that, but it's actually pretty simple. This one, really simple. They give us an equation. You get an equation. You just throw it into Desmos, right? You throw it into Desmos, and you're going to figure out what x is, right? Here's x. It's negative 2.25, right? And then I can use that to answer this question. So it's 2 minus 4 times negative 2.25, right? And we get 11. Next one. Scientists studying the life cycle of dragonflies counted the number of dragonflies in a certain habitat for 46 days. On February 15th, there were 99 dragonflies. The percent increase of the number of dragonflies in the habitat from January 1st to February 15th was 12.50%. How many dragonflies were there in January 1st? Okay, so here's the deal with this one, right? A lot of people are going to get this wrong because they're going to think about it in a way that seems to make sense and it doesn't, right? So we know kind of how much dragonflies we have at the end. And they know that it increased by 12.5%. So a lot of people are mistakenly going to believe that if you do the opposite, you'll get the original. And that's not how percents work, right? So if you had a 10% increase, you can't do a 10% decrease to find the other value, right? It just doesn't work with percents. That's a normal thing in math where we do the opposite, right? But it does not work with percents. Here's what you want to know with the percents one, right? Here it is. This equation is going to be super useful. Final equals original times your 1 plus or minus r, which is your increase or decrease, right? You can use this to find 3 different things: the final, the original, or the percent, right? So this is what we're going to use here. We know the final because we know at the end on February 15th, there were 99. That's final. We don't know the original. That's the January 1st. We want to figure out how many were there on January 1st. And we know it was a 12.5% increase. If it says a certain percent increase or a certain percent decrease, you have to write it that way, right? Because it's not the simplest thing to figure out like what that would be, doing the opposite, right? But you see, I just write this equation in, make my unknown x, and I can just click on it and I get 88. So make sure you know that equation. Next up, we saw this, I think, on the very last video, right? It's a quadratic equation. One solution can be written as this. This is your quadratic formula. Hopefully you kind of like recognize that because it's like negative b out here plus minus square root over 2 times a, right? So you're basically, k there is the discriminant. It's b squared minus 4ac, right? So if you know that, that's the quickest way to solve it. If you kind of see that, I'll show you another way you could do it as well. But honestly, this is going to be the fastest. Is just 120. Here's the other way you could do it though. Remember, because this also has the keyword solution, and we know with solutions, if I type them into Desmos, right, I can find the solution. So here they are, these two. This one's talking about the smaller one. The reason I know it's a smaller one is because we're doing something minus the square root. So that'd be the lesser number. So this is my solution, right? And what I can do now is, you see, I know the solution. I can set it equal to this because they tell me the solution is going to be the same as writing 8 minus square root k, right? So I write that over 4, right? And you see, if I zoom out, I should be able to see what that value is, and it's still the same 120 that we had before, right? That's a different way. Next up, 21, function defines f of x as 19 more than 4 times a number. It is graphed in the xy plane. What is the best interpretation of x-intercept? Okay, so intercept question again, interpretation, right? So whenever you have an intercept, right, we talked about it for the other one, it just always, the other variable has to be 0. So if they're talking about an x-intercept, we know y has to be 0, right? And check this out. They almost always write this in every function problem. Y equals f of x, right? We want y to be 0. You see, that's literally what a is saying. Y, 0, and equals f of x, right? That's it. It's just a, right? That's what you got to look for. Next up, last one here, module 1. This is pretty simple. You could do this in Desmos. The only thing you got to know is Desmos by default is not in degree mode. The way you change the mode in Desmos, you go up here to this wrench, this this wrench up here, and you can just down here swap from degrees to radians. So anytime you start a new test or open up a new Desmos, right, it's not going to be in degree mode. So make sure if your question does have degrees, you change that, right? Otherwise, you're not going to get the right answer. So I just typed this in, you see, just exactly how I see it, and it tells me it's 1. Now, one of these answer choices has to be 1. So let's try A. So I type in A, right? Is that 1? No, that's not 1. So then let me just put a plus here and put 2. That's B. So is that B? Actually, B has cosine here. So that's not it either, right? And then I got to get rid of these 2's and make them squareds instead, right? Let's try C. There it is. That equals 1. So we're done, right? That's it. Module 1. Honestly, pretty straightforward there. Nothing, you know, too insane. Quick break before Module 2. Want to show you something I built. Here's the reality about SAT math. Watching someone else solve problems does not make you better at solving them. What makes you better is doing hundreds of them yourself until you stop thinking and just solve. When you've done 50 linear equation problems, the 51st one isn't even a question anymore. You just see it. That's the level you want to be at before you walk in. All of these are obvious to me just because of practice. That's why I built Sigma Prep. Every SAT math topic organized by difficulty. You pick a topic, you practice. Every time you get a question wrong, there's a video explanation of me breaking down exactly how to solve that specific problem. You watch it, you retry it, you lock it in. No more getting stuck and wondering what you did wrong. Let me show you real quick. Say I jump into this topic here, I get a question, I answer it. If I get it wrong, right here, video explanation. I can watch exactly what I would do, then try it again. Every topic works like this. Every topic is free to try. Jump in, start practicing right now. And if you want to know where your weak spots are, take the diagnostic quiz first. You'll come out knowing exactly what to focus on. Bottom line, if you put in real reps with real feedback, there's no way your score doesn't go up. SigmaPrep.io, link in the description. Back to Module 2. Module 2 here, let's just jump right into Module 2. Okay, open up Desmos. We got a bar graph. It says for, you know, how many of these 15 days did it receive a charge of 0? Honestly, pretty simple question, 6. Next one gives us a graph. What's the slope, right? So we did a slope question, you know, in the first module. Add a table, find 2 points, right? So to me, this looks like 1 comma, maybe a little bit more than 3. So I'll go 3.1. And then I got to find another point here. It looks like 3.7. That looks nice. So 2 points from the line, hit the regression button. I get 1.95 for my slope. So 2. It says closest to. When it says like closest, you know, probably not going to get an exact answer, but there should be one that's much closer than all the others. Next one, another percent question, right? This one's a little different though. It's not percent increase or decrease, right? So it says in a sample, 80% of the items are faulty, right? There's 2 ways you could do this. You could literally kind of like make, you know, a proportion. You could say 80 over 100, right? And then we want to know, we know how many are faulty actually. We want to figure out, you know, what's the total. So the bottom like represents the total here. So you see, I can write this and then I can look at Desmos and see that this answer is 110, right? So that's probably one way to do it. The other thing is you could just make an equation. You could say like 80% of, you know, the items, which we don't know, are faulty. And you see that gives you the same answer that way, right? So translate that into an equation. This one, we got a table. There's a couple ways you could do this. I think the easiest way is just, you know, throw in a table, right? Put these points in. All right, and 2 and 1 over 625. And what we'll see is we'll see these points graphed, right? So here's our points. Now, the correct equation, what we'll see is the correct equation will just go through these points. So what I would do is just like put these equations in then. G of x equals negative 25 to the x. You see, this doesn't go through any of those points. That's not it. I'm going to try C because they're basically the same. So you see it's not C. Let me go to D then, 1 over 25. Yeah, you see 1 over 25. That's it, right? So pretty straightforward if you could approach it that way. Next one, we've seen this before. Honestly, this one's even simpler. If you get an equation, just throw that into Desmos. You see I throw this into Desmos. It tells me what x is. Now I know what x is. I can do 72 times that number, right? And that's it. So honestly, pretty simple here to start Module 2 as well. Next one, exponential. We got exponents, right? Not exponential, exponents, right? You got to know your exponent properties, right? So let's kind of go over that really quick, right? I don't think I have a photo for it, so I'll just kind of write some examples. So remember, there's 3 properties. They're pretty simple. If you have, you know, if you're multiplying things with exponents, right? You just got to add them. If we're dividing, like in this example, right? We're subtracting them. And the final example is like, if you have an exponent, right? If I have an exponent and that has an exponent, right? So we can say something like this, then you multiply them. Those are really just your 3 rules that you got to know, right? So like over here, you know, they have h to the 15, q to the 7, and then h to the 5th, and then q to the 21 on the bottom. We just got to simplify this using this division property, right? So you subtract the h's, 15 minus 5, that's 10 on top. So could be A, could be C, those have that. And then finally the Q's, the bigger Q's on the bottom. So you're going to leave Q on the bottom. And yeah, it's 14, 21 minus 7. So know those 3 properties. Those are pretty simple. Next one, a company fills boxes with 23 pounds of oranges. To test the accuracy Of the filling process, 344 boxes of oranges were selected at random and weighed. Based on this sample, that it is estimated the average weight of all the boxes is 23.1 pounds with an associated margin of error of 0.19 pounds. So this kind of comes from statistics. It's a pretty simple idea. You know, you may not have seen it though, right? So you got to know it. Margin of error, it's kind of what it sounds like. Error is just like how much something could be incorrect by, right? So we weighed these boxes and we got 23.1 pounds, right? But we have like an error of 0.19 pounds, right? So the way you kind of like use this, right, is we're going to basically set up a range, right? Anytime it's margin of error, just think plus minus, right? So we're going to take 23.1 and we're going to say like maybe we're, you know, like we can have 0.19 pounds more, or, you know, we can have 0.19 pounds less, right? That's what margin of error does. It establishes a range, right? And this is the range. This is the most likely range, right? That's the way you're looking for an answer choice, right? That it's probably between these two numbers, right? It's not a definite thing, right? So sometimes they'll have like answers that sound definitive, like this is not possible, or, you know, it's most likely, or it's like unlikely, right? You don't want answers that say like it's definitely this, or it's definitely not this, right? So that's A here, basically. It says the plausible, you know, values are between these two numbers, right, that I've calculated there, right? So pretty simple. This one, also really simple, right? It's another one that's asking for the solution, right? Hopefully your June test, if you're taking that one, or whatever test you're taking up next, right? You get a bunch of these, right? Don't miss them. You can just throw that into Desmos, you see. Just make sure you type everything incorrectly. That's the only way it could go wrong, is if you just type something in wrong, right? So that's, what was that? That was 42, right? So simple. Next one, we got our functions, right? So if I type these functions in, I'm going to get an error for G, or for the f of x, because it doesn't know what b is, right? So it's important we kind of understand why we're getting an error. It kind of gives you a hint sometimes. It doesn't know what b is. But you see, that's the question. The question's asking us, like, for what value of b. So if I told it, like, we're going to just start with A, if I tell it B is negative 26, you see now it draws F and G and there's no errors. Now the question though, the question wants us to do F of X times G of X. You see, I can do that. I can have Desmos do that, right? I don't want to look at, you see the graph is getting kind of messy. You don't want to look at F or G specifically. We're really just interested in, you know, this product. So this is what it looks like, right? And they're telling me that it has to equal this, right? So basically, this has to match this one. So I can then put in 9x to the fourth minus 26x cubed minus 3x squared. And I can see, are these the same? And they're clearly not the same, right? You know, so they're different graphs. So I know that B is wrong for that reason. So I try the next answer choice for B, right? Negative 26 over 9. Still not the same graphs, right? Then I try the next one. Let me try 1 over 9. I don't see another graph. I think this is it. Sometimes it's hidden under the other one. So you see, if I turn off the green one, there it is. The blue one's underneath it. So that's how I know that's the correct one. Next one. In xy plane, line S passes through 0, 0 and is parallel to the equation y equals 18x plus 2. If line S passes through 4 comma D, what is the value of D? So here you got to be a little bit more careful towards the back half of module 2. This is when they will increase the difficulty and just maybe like word things a little bit in a trickier way. Got to read more carefully, right? A common mistake people are going to make for this is they see this equation and they're going to just plug in, you know, 4 for x, right? And that's what we want to do, just not in this equation, right? So it's not 74, right? If you read carefully, they're describing to us line S. That's the line we got to plug it into. This is not line S. It said line S passes through 0, 0 and is parallel to this, right? Remember what the word parallel kind of means, right? Parallel is just same slope, right? So you see, I know this one has a slope of 18, so I know my equation that I want to write has a slope of 18. Next thing though, I need to still know what the B is, right? The y-intercept. And that's what this point is, right? It's literally the y-intercept, because remember we talked about intercepts. If it's the y-intercept, x has to be 0. So x is 0 here, right? So this is going to be plus 0, or you don't even really need that, right? I'll just write it anyways. And then y equals 18 times 4. Now we plug in 4, you see we get 72. So just be careful. This one, pretty simple, gives us an equation and it's talking about a minimum, right? So if you just type this in, you know, you can always click on the minimums or maximums, right? So minus 44, x minus 46. Let's see. Okay, there it is. Okay, so you can just click on the minimum. It's 45, right? Make sure you answer the right one. You see they have 45 and negative 1. It says for what value of x, right? So the X was 45, right? Also, you gotta be careful sometimes if you're too zoomed in on like, a previous problem. It could look like you're clicking on the minimum, but you see like that's the X-intercept because all those points were really close to each other, right? So just make sure you're zoomed in and clicking on the correct one, right? But that should be a freebie. Next one, triangle XYZ, angle Y is a right angle. Okay, we gotta sketch this, right? So that's why you still have kind of graphing paper and things like that, right? So I can go ahead and draw this triangle here, right? Let's go ahead and draw this. And it's a right angle, so we can do something like that. And they told us that Y is the right angle. That's the only one that really matters, right? And then X is over here, and then Z is over here. Okay, so that looks good. Let's see what else. It says P is on XZ and Q is on YZ, right? So let's kind of go back to that. So we can put P on XZ and Q on YZ, and they say we can kind of connect them, and they say they're parallel, right? So this is also, a right, angle there because of, our corresponding angles. So when you have parallel lines, right, where's our, angles, here it is, angle relationships, right? You have corresponding angles, right? That's kind of what we're dealing here, like 1 and 5 as an example, right? They got to be the same. Okay, what else does it tell us, right? It tells us the measure of XZY is 63, and they want to know XPQ. So let's take a look at that. XZY, so that's up here, right? So we can put 63 here. Let me move that down. And then also they want us to figure out this one, XPQ, right? So I'll mark that with X. So this is pretty simple. You see, you have this angle here. You can already figure out this one, right? This is going to be then, what would that be? It's got to be complementary. So that's going to be 27, right? And so then over here, 27 and X, this is going to form a linear pair, right? This is another relationship we want to know. So our linear pair. So we're just going to do 180 minus 27, right? And we're going to get 153. So that's it. But you got to sketch those out. That's why you have scratch paper still, helpful for the geometry ones, right? Okay. Next question. This one. Okay. Interesting. This is a weird one. You probably won't see this again, right? But we'll kind of go through it. So we got to kind of know how to represent, like consecutive integers. I remember this question. I've seen it before, but I've never seen other questions ask about consecutive integers. So you probably won't see it, right? So when we talk about consecutive integers, right, it could be like consecutive integers. What that means is like if you have consecutive integers, it's just one after another, right? So I could do something like this, 1, 2, 3, 4, 5. The way you'd represent that, because you got to know how to represent them, that's the key to this problem. We'd say like the first one's X, and then the second one would be 1 more. Then the third one would be 2 more than the original one. Then the fourth one would be 3 more than the original one, and so on, right? This is the pattern. But this one says consecutive odd integers, right? If you have odd integers, right, what that means is like we're skipping, the even ones, right? So it's a little different. We'd still say the first one's X, but then you see the second one's going to be 2 more than that. And then the third one's going to be 4 more than the first one, and then 6 more and 7 more. Or 8 more, sorry. But basically you just need to know like how to represent these, because then this is a pretty simple problem because it tells you the product of 12 and the fourth integer, right? What's our fourth integer in this list for the odd ones, right? You see it's X plus 6. That's how you'd represent the fourth integer. So it's right away 12 times X plus 6. So it's not C or D. And then it tells us is at most 26 less than the sum of the first and third, right? So 26 less, that means it's got to be A, right? When you have less than something, you write that at the end, minus 26. But you can also see first was X, right? And the third integer here, X plus 4, right? So that has all this. Honestly, you probably won't see that. I've done I think almost all the Bluebook questions, all of the question bank questions, right? Just thousands of questions, with my students. And never think I've seen another one of these, right? So probably I wouldn't bank on it, right? Next one here though, this one, you do want to know. This one in contrast will definitely be something you can run into again. It gives us a system and it tells us it has infinitely many solutions. So this is something we need to know, right? So when you have infinite solutions, right, this is a special case for lines, right? It means I think of one word, this helps me remember it. I think identical. On a graph, they would be the same thing, right? Identical. But also as equations here, you see this is an example of something that's infinitely many solutions. They literally have to be identical. So what they're telling me is that this equation and this equation have to be the same. So we got to figure out what value, would make these kind of the same. So let me write this in here. You do got to do a little bit of algebra. This one is kind of annoying, but It doesn't get worse than this, right? So what I would do here is, get rid of the fractions, right? So like for this top one, I'm going to multiply by 35. If I do that, it's going to become 14x plus 49y equals 10. And then this bottom one, I'm going to multiply that by 2, right? And that's going to be 2gx plus 2ky equals 5. So now I'm not done yet because these are still not the same, right? So this one equals 10, this one equals 5, right? So I still got to multiply this one by 2. So you see, that'll actually become 4gx plus 4ky equals 10, right? Now they're the same. You see 10, 10. So what does that tell me? It tells me 14x has to equal 4g. So in other words, 4g equals 14. And over here, 49y equals, this should be 4ky. So 49y equals 4ky. So it's 4k equals 49, right? And now you see I can figure out g and k. I just got to divide them by 4, right? And now I have my g and I have my k. Now I can answer the final question, which is what's g divided by k? And I can ask Desmos to do that. And I can enter it in as this decimal, or I can change it to a fraction and I get 2/7, right? I have more of these problems. Almost this identical problem, just mixed up, obviously different numbers. Practice problems on sigmaprep.io, right? So it's not a surprise to me because I've seen it, I've practiced it a bunch of times, right? And that's the whole key, right? You don't have to be a genius. You just have to be prepared enough that nothing will surprise you, right? So this is the worst they'll get, a little bit of algebra to get rid of fractions, right? But you practice it enough and that should also be pretty simple. Next one here. This is a question I've seen a bunch of times. People get this one wrong, and it's actually very simple. You'll probably kind of like laugh at how silly and simple this is after I explain it to you. But most people honestly will get it wrong if they haven't seen it before. And again, I have this same exact problem, right? Somewhere in Sigma Prep, you'll see basically the same type of question, right? So Sigma Prep is just there, honestly, for you to just practice a lot so that these things become super obvious and there's no surprises, right? So some of the things aren't intuitive, honestly. If you haven't been prepped, right, they're not going to be intuitive, but it doesn't mean that they're hard, right? You just need to do enough practice. So here's what I would do for this one. You see, we're getting errors. Why are we getting errors? Because it doesn't know what S is. So we just tell it what S is. We can say like 5, right? You can use probably whatever you want for S, right? Sometimes they'll tell you like it's positive or negative or whatever. Never use 0, never use 1. Weird things happen because of 0 property and identity property of 1. And also don't kind of use any numbers you see in the problem. Sometimes that will kind of mess you up. So I'm going with 5, right? And now you see I plotted those and the errors went away and it showed me my 3 points. And we saw this earlier, right? If I want to know what's the correct equation, now I'm just going to enter these and it should pass through those points, right? So we kind of saw this idea earlier as well, right? And yeah, so this isn't it. The only difference was now they had S, so we got to know just, okay, plug something in for S. Not A, and then we try B, and we see, yeah, B goes through all of them, right? And check this out. I can change the value of S, and you see this equation always has those points, right? So yeah, it's B. Next up, this problem. Okay, Y equals K. Okay, this problem is a discriminant problem, right? And this is what you're training, right? You need to develop what I call problem recognition, and that just kind of comes through grinding problems, right? I know this is a discriminant problem. How do I know it's a discriminant problem? It has a quadratic, right? And it's telling me how many solutions it has, right? That's one of these 3 cases we got to remember. Here it is actually the one solution case, right? So what I want to do is I got to get a quadratic that's set equal to 0, and then I can just type one of these things into Desmos. That's all it is, right? So I know it's a discriminant problem again because I see a quadratic. I see that's telling me how many solutions and that there's like an unknown. That's your discriminant problem. Almost every practice test is going to have this in like module 2 at the end. Sometimes they have a couple of them, right? So what I'm going to do first is I'm going to write these equations in terms of Y equals, right? Because I got to do a little bit of algebra first to set this up, right? So it'd be like this, and then we set them equal to each other because it's a system, right? And then finally, I can set this equal to 0, right? Because we want a quadratic that's equal to 0, right? So it's going to be like this. I subtract the x, it's minus 6x. I subtract the 26, it's minus 26, and I add, k, so it becomes 2k. So now you see a is 1, b is negative 6, and c is this, negative 26 plus 2k. Now back to my discriminant, right? I'm just going to use this. I'm going to type in b squared minus 4ac equals 0 because it's the one solution case. So it's negative 6 squared minus 4 times a times the c and equals 0. So still an error because it's an equation. Remember, we talked about this a few times, I think today already in this video alone. It's got to be x for Desmos to like solve an equation. So swap the k to x and you get your answer, 17.5. Simple. Next one. This is really simple. I don't know why this is question 17. We've done this, I think, like this is the third time at least this test, right? Just type your function in, type f of 4, we get 5. All right, I'll take that, freebie. Next one says area rectangle is 2,661 inches. The banner's length x is 24 inches longer than width. Okay, this is a tricky, it seems like a harmless question, but a lot of people get this wrong, right? You'll probably fall for this trap if you haven't seen it. And again, that just kind of comes down to practice. You do enough practice, you kind of see like how they try and trap you, and you're more aware and you don't fall for those things, right? Do your practice. I have a lot of that set up for you at sigmaprep.io. This shouldn't be a surprise then, right? So you see, I know the area is 2,661. What most people are going to do is they'll do this. They'll do x times x plus 24 because they read that it's 24 inches longer than the width, right? And then you'll pick the trap answer, right? Here's why. It tells you the length is x, right? So I got to make length x. So you see, what I got to fill in then is the width, right? But if you read this carefully, you know, you wouldn't write x plus 24 for the width, right? Because it's telling you that the length is 24 inches longer than the width, right? So what's the width? It's really 24 inches less than the length, which was our x, right? So be careful with that, right? Most people are going to make that mistake, and then you kind of like realize as you make a mistake what kind of the trap was, right? So that's the thing. Just do your practice, right? And you'll kind of see like all the ways they try and mess you up. So distribute. And set it equal to 0. And we get this. This is what we're looking for, which is answer choice A. All right. Next one, right circular cone. So here's our formula sheet becomes useful again. Here's our cone down here. Just going to throw that formula in there. V equals 1/3 pi r squared h, right? And it tells us the volume. It tells us it's 71,148 pi, right? So I'll plug that in for V. And then it tells us that the area of its base is 5,929 pi. So if you look at that picture again, the base is a circle. So this second part is really just telling you the area of a circle is this, right? And we talked about that in another problem before, right? So I know area is pi r squared, and now I can plug that in for the area, right? And you see, I can actually figure out r now, right? That's going to be part of the problem we want, right? That's where we start. Because we can't do anything with the volume one yet because it has r and h. But I can figure out r if I just change r to x, right? You see Desmos will solve it for me. So I know radius is 77. See, if I know radius is 77, I go back up here, I replace radius with 77. And if I want to find h, I change h to x, right? Ignore these other graphs. We want the blue one. That's our h. So h is 36. Now, final question, just be careful, don't pick that. Some people do. That's not the slant height, right? It's a weird question, the slant height. Usually they don't ask that, right? But the slant height, you see, if you look at your picture, it's this one along the kind of like outer edge, right? And so what's the relationship? Your height, which goes straight up and down, and your radius, they form, you know, a right triangle. So that means we're going to use Pythagorean theorem for the last step to figure out this slant height. So you do that in Desmos too. 77 squared plus 36 squared equals x squared, right? To figure out like the c, and we see that that's 85, right? So that's it. The only other one that can have slant height is this pyramid. I've never seen a question about pyramids on the SAT or in any of the questions, so you probably won't get that. Next question, 20. This one's a silly one. And again, if this is something, if you haven't seen before, you'll probably overthink it and get it wrong, but it's actually pretty simple. If you put this into Desmos, right? You see a line, right? And it's the same line. This is like infinite solutions because they're the same exact line, right? Now, this question is actually really simple. It's telling you which point lies on the graph. So one of these literally has to be like on our graph. So if I type in A, right, it's not going to draw a point until it knows what R is. So just like we saw that other problem where we plugged in for S, plug something in for R. If you write R equals a number, it's going to draw a circle with that radius. Just ignore that. But here's our point, right? So that's not it. So then I just try answer choice B then, 7R over 6 plus 5 over 6, right? Where's that? That's not it, right? Then I try, you know, C, that's going to be R over 4 plus 5, negative R over 4 plus 20, right? I got 0.4 here, careful. But yeah, that's not it. So it should be D, let's see, unless we wrote something in wrong. If nothing's on there, just you made a mistake typing something in somewhere, but let's check this. It's the missing one, 7 plus 5 over 7, comma R. There it is, it's on the line. And you see if I change the value for R, it stays on the line, right? Okay, 21 here. This is another question most people will get wrong unless you've practiced it a bunch and you know exactly what you want to do, right? Same thing with that last one I did. I knew exactly what to do just because I've seen that question a bunch of times, right? You know, so they reuse things, right? And if you do enough practice, you kind of know. Most people will get this wrong because they'll just kind of read it, you know, and it says it's $52 for the first day and $26 for each additional day. They'll probably pick, you know, B, 26 per day plus 52. That's wrong, right? It's not going to be that straightforward at the end of the test, right? At the beginning of the test, probably, yeah, it is that straightforward. Here, that if you ever find, like, for the most part, if you ever kind of see a question here towards the end and you're in the hard part of module 2, you're like, oh, that was really simple. It's probably you got kind of caught by a trap, right? So what you should do is you should just get Desmos to give you the equation, right? And to do that, you just got to give it 2 points, right? And so to give it 2 points, you got to know what X and Y are. So X here is the days and Y is the cost, right? It tells you D days, that's the X, and cost, right? And so you see, they're literally giving us a point. First day, $52. So 1 day cost 52 and 26 for each additional day. So like a second day, right, is 26 more, it's 78, right? Do your regression, right? And here's our equation, right? And you don't fall for the trap. So next one, last one actually, is a conversion problem. So, you know, unit conversions, that's something we want to know. I have something for unit conversions. There it is, okay? It's just doing basically dimensional analysis. You know, if you've taken chemistry, you did stoichiometry, you just got to line up your units and make sure everything kind of multiplies and cancels out correctly to leave you with what you want, right? The reason this one's tough is like when it's at the end of the test, they'll always have like one of the units being squared. You got to watch out for, right? So you see, if I write this, I'm going to write 7.3 meters, right, and it's 1 second squared. So that's kind of like what we're starting with, right? We want to end up with miles per minute squared. So first thing, I'm just going to change meters to miles, and they give us that conversion. They'll give you pretty much any conversion you need except, you know, the time ones, right? So you see, I know to put it like this, 1 mile over 1609 meters, because I want those meters to cancel out, right? Next up, I don't want seconds, it's got to be minutes, right? So like I said, they won't give you those, but it's 60 seconds to 1 minute. Everyone knows that, I believe. But you see, people are going to make a mistake. They'll leave it like this, and there's going to be a trap answer. I'll show you that when I actually calculate it. It's not going to calculate it because it has the units here. But this is incorrect because this is seconds squared. It's not going to be canceled out by seconds, but it's a simple fix. You just square this, right? And now you see, I just enter all of this with the numbers without the kind of like units. Units are there just so I make sure I line up everything correctly. You see, this is the trap answer if you do not square it. You see that one's waiting for you. They always have that, but we know better. We square it and we get 16.3, and then that's kind of it. And that's it for module 2, right? So again, I think the only weird one was the one with the consecutive integers where I say you don't have to worry about that, but everything else as expected and seen before, right? So you do enough practice, there should be no surprises, right? So just make sure you kind of get on that. So let's check out the score. And that's another perfect 800. Look, the reason I can do this isn't because I'm some kind of math genius. It's because I've seen every type of problem enough times that I recognize them instantly. That's the whole game, problem recognition. When you've done 50 of the same type of problem, the next time you see it, it isn't even a question anymore. You just instinctively know what you're going to do. You just do it. That's what SigmaPrep.io is built for. Practice problems by topic, video explanations when you get stuck, and enough reps to make the real test feel easy. You should be able to walk in and know at least 90% of the test, right? Subscribe so you don't miss the next speed run, and make sure you like the video. Thanks for watching.